All right, so hey, we're ready to start the next thing. We're going to do an introduction to trigonometry. So we're not going to go into detail as much as maybe we would like, but we are going to make sure you kind of have a good understanding of this, because for those of you that may go into pre-cal, you are going to get into this very deeply. Anyway, so we're going to split this up a little bit, but we're just going to start off with something simple, like starting off with trigonometric ratios using right triangles. Okay, so today you're going to find trigonometric ratios, and we're going to see how you can kind of apply that maybe later. There is going to be a lot of calculator work on this, so kind of go with that. Anyways, what is trigonometric ratios? Well, trigonometry is the study of, I'll just stop it right there. It's basically it's trigon, and metric or metroid. Trigon and metron. Trigon meaning triangle, metron meaning measure. So basically this is a geometric word for saying triangle measurement. In a right triangle, we're going to start off with a right triangle. In a right triangle, a trigonometric measurement, there are three things that we look at. We look at sine, cosine, and tangent. Okay, there are others like secant, cosecant, and cotangent, but these are our basic three. These are the ones we look at. And what is sine? Well, sine is basically the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and I'll explain what this means in a minute more. Tangent is the opposite over the adjacent. Okay, this right here refers to sides. I'm trying to write the word sides here. Let's do it over here. But when they're referring to these things right here, they're referring to the sides. And you're going to have, like, say, sine theta, cosine theta, tangent theta. Those right there are referring to angles. Okay? So, if I wanted to here, I can go, all right, here's A, B, C. And there's little a, little b, little c, so we know that those things go together. Okay, so sine of A, which means sine of angle A. That means then I want opposite over the hypotenuse. Okay, so in this case that would be just little a over, opposite over hypotenuse, yeah, little a over little c. Sine of B would be the opposite of that, which would be little b over c. Cosine, and you can kind of see how this works, cosine A is B over C, cosine B is A over C. Notice how those kind of flip-flop. Tangent of A is A over B, tangent of B is B over A. Okay, so you can kind of see how that works. I would have these definitely on my note sheets until you get really used to them. The more problems you do with these, the easier these will be. Okay, so let's look at, again, also make sure that your calculator is in degrees. For some reason, a lot of calculators are defaulted into radians, and you need to make sure you're in degrees. There's two ways that we measure things. We now measure things in degrees, but back then the Greeks were measuring things in what they called radians, which means in terms of pi. So you need to make sure your calculator is in degrees to get the answer that you need. Okay, so here we have an example. Here we have a right triangle. We have two legs that are 8, 15, and 8, and then we have a side, or a hypotenuse that is 17. If I wanted to find, say, sine of P, sine of angle P, this one right here, that one right there, that one right there, okay, I can go opposite, which is 15, over the hypotenuse, which is 17. And that will give me an answer of approximately 0.88. Using that, later on I'll show you how you can use that answer and find out what the angle was of P itself. But for right now, we're just wanting to find that. So just divide that out, get that answer. If you want to leave it as a fraction, we could even do that, because the main thing is that you're understanding which is which. Cosine of P is going to be the adjacent, which is 8, over the hypotenuse, which is 17. That's 0.47. Tangent is going to be 15 over 8, which is 1.88. Sine is going to be sine of Q. Now notice how I'm going the opposite. Now this one I'm going 8 over 17. And you might see a relationship between sine and cosine of the different angles. You notice that some of these numbers are kind of repeating. And then finally, tangent of Q is 0.8 over 15, which is 0.53. So there you go. Those are pretty much like that. That's a quick and easy example. And again, the idea here is make sure you understand when I'm using opposite over the hypotenuse, adjacent over the hypotenuse, or the opposite over the adjacent. All right, so now on this one, okay, so here I go. This is a little bit different. This is where I think trigonometry really gets to show you some of its strength. How do you find, you only have one side of a right triangle, and you have an angle measure. How do you find another side? Okay, they're not giving you, like, say, two sides, and you can't do the whole a squared plus b squared equals c squared, although this was kind of built off of that. So what they did here, what you do, is first off, like, identify which one are you using. Are you using sine, cosine, or tangent? Well, if you look at this, you've got two sides here, one that you got to find and one that's given to you, and they aren't the hypotenuse. Okay, so if you're not using the hypotenuse, or you don't have any access to using the hypotenuse, you're going to use tangent. So I'm going to say tangent of 25 degrees. So that's notice how I've got the angle with the tangent. Then it's opposite, which is x, over the over the adjacent, which is 18, the one that touches the angle. That's what adjacent means. All right, well, how do I solve that? Well, to get rid of division, you just got to multiply. Okay, so if I multiply 18 times the tangent of 25, it gets rid of that 18 on the other side. I could type that into the calculator, and I would get 8.39. Okay, and again, this is one of those, the more you practice with this, the easier it gets. And this leads to so much possibilities that if you understand this is actually can be used in so many different career fields that it's kind of like fascinating to me. But realize that you've had all this math that you needed to get to understand this. So for all that, when are we ever going to use this? It's to help you build up a knowledge base that you can get to the math that you can actually use. Anyways, I got on a rant there. All right, let's look at this one. This one is cosine, because you notice this is the adjacent and they're giving you hypotenuse. Really, right when you see this x right here, you know you're either using, because that's the hypotenuse, you're going to use either sine or cosine. Okay, you just got to decide which one is it. Well, the 15 is touching the 70 degrees, so that means you're using cosine because it's adjacent. All right, as compared to using sine, which would have been the opposite. All right, so cosine of 70 over 15, the adjacent over the hypotenuse. Well, how do I get rid of this? Now, the nice part about this is, if the x is on the bottom, all you got to do is switch those two, the x and the cosine. So this is really x is equal to 15 divided by the cosine of 70. And then when you divide that out, you get approximately 43.86. And there you go. And that's really all this is. Now, I will, of course, spend more time in class to go over this with y'all to try to make sure you get this. But that's it. And there you go. Anyways, that's it for today, guys. Thank you so much for your time. Y'all take care.